Okay, so the title of this module is Analyzing Vulnerability Scans, matching to your certified title. However, if you've already read ahead, you'll see that it's way more than analyzing vulnerability scans. This is where we're going to learn more about specific vulnerabilities also. That's going to be the second half of this lecture. So this is kind of a long one, so dig in. Why is all this stuff important, though? These are your objectives for CYSA Plus exam. So here we're going to discuss the different scanning methods that you can use. We hit those a little bit. Better yet, though, we're going to talk about how all this plays into the analysis side, because sometimes you're going to run a scan, you're going to have like 1,000 vulnerabilities. Which ones are important? Which ones are not important? Which ones require you to take action on right now? And which ones are kind of like information only? Okay? And then we always want to, on our side of things, on the defensive side, we're always going to recommend how we're going to mitigate that attack. How our audience, whether it's a customer or a consultant, or whether we're working in a security department and our customer is like an IT operations department, and we're going to recommend to IT operations what they need to do to resolve a vulnerability or mitigate one. So the first big thing is this reviewing and interpreting scan reports. So we've seen these scan reports. We've done some labs on scan reports. Yeah, let me see if I turn this brightness up. I just bought a new projector over the spring break. I'm going to play with projector settings. That's not going to help at all. Okay, so we've seen this. If you've used Nessus, you've kind of seen this vulnerability report, right? You run the scans. You run that configured scan. We did the uncredentialed scan. We did the credentialed scan lab. And what you end up is you get the little hits in there with different kinds of vulnerabilities. You click on it, and you end up with something like this. This is what your Nessus report looks like. So when I tell you it's your job to recommend controls and provide information, how hard is this to do? What's that? Yeah, make mitigation recommendations, because the great thing is that CISA and MITRE and US CERT, they've done this for us. They've done this for us. And that's what makes it really cool. Now, I will say that your job, your specialty, is going to be able to turn this into something that people will understand, okay? Something that human beings will understand, because I will say that as IT professionals, we are kind of viewed as superhuman, because you can read this and it just makes sense. Is this out of focus to you? No? What's that? Good. Is it? But when you read this, and this is in your text too, this is just a picture from your text. When you read this, though, it's going to read like Greek to what I call a normal human being. But we'll just read this, description. The remote service accepts connection encrypted. The remote service accepts connections encrypted using SSL 2.0 and SSL 3.0. These versions of SSL are affected by several cryptographic flaws, including an insecure padding scheme with CBC ciphers, insecure session renegotiation, and resumption schemes. You may understand this by the end of this module or by the end of this course, but who else is going to understand that? Yeah. So you have to consider your audience. You may have to realize that maybe you're sending this up to an information security manager that has manager certifications, whereas we're talking about technician level stuff here. So you may need to lighten this up. Meaning, so we're speaking CYSA plus SOC technician language, but you may need to enhance this to SOC manager or maybe chief information security officer language. So you need to be able to deduce this into like business language. Okay, and that, if you can do that, you're going to go far. You're going to go really far if you can translate this to what I call human, right? And that's a 5th to a 7th grade reading and understanding level. So, but this is what a Nessus report looks like. The big thing on this Nessus report, and the next one is going to be the Qualys report. You may not have seen Qualys reports except for in your book, because Qualys' online service costs a lot of money. But again, still, it's the same language. It's the exact same language up here with links to click on. So you could take all the information here, and you can write a threat report, and you can write mitigation controls, and you can make a recommendation. All you're doing is rewording it. And I wouldn't copy and paste this into a report or into an email, but what I would do is I would report this in the human, again, like as a human, non-IT language, but then put a hyperlink. So when I write my threat reports, I will say, this is APT29 China or whatever. And no, that's Russia, sorry. APT29 China, advanced persistent threat. And then I'll write like an executive summary level of what that threat does. But then the first time I mention APT29, I will hyperlink it to MITRE. I'll put a little Word document link in there. So if that person really wants to dig in depth on APT29, they click it, right? And that means I don't have to type big information briefs on APT29. If a technical person wants to read more about it, they can just go right there. I can pick the top 3 mitigations from that document, but they can read for more if they want. But these 2 documents are going to give you basically whatever you need to relay to your customer. And I do like to consider everybody a customer. That you'll hear me say that a lot, whether you're a consultant working for an actual paying customer, or whether you're an IT security person and you're providing a report for another department within the company you work for. They're all customers as far as I'm concerned. So now we pivot a little bit into CVSS, right? Common Vulnerability Scoring System. We've seen this before, but we've seen the number, right? Whether it's a 1.0 or a 9.9, we've seen the number. But how do we come up with this number? Interesting, right? Not a whole lot of math in our cybersecurity courses, but this one involves math. Okay, but it's important for you to understand how we come up with this number. So 2 critical aspects to it. We want to evaluate the exploitability of the vulnerability, but then we also want to evaluate the impact of the vulnerability. And then each one of those columns, we're looking at the attack vector. We're talking about the attack complexity, privileges required user interaction. And then on the other side, we're looking at the CIA. CIA triad is a repeating topic in all cybersecurity courses. And then the scope. Okay. So we break down the attack vector metric: physical, local, adjacent, or network. You see how these numbers likely go up? Why would physical be low?
Or it's good.
I require physical access to exploit this vulnerability. So, that could be a very high consideration at this campus because I can get physical access to a lot. But think about it if you're at a secure business that maybe the servers, the workstations are behind 2 or 3 block orders. They're access control. So, but that's why that's lowest. The network is the highest because the threat actor can be anywhere. They can come in from the internet. They can come in from a public access terminal here. They connect via Wi-Fi. Okay. Local, on the other 2, the attacker must have physical or logical access to an affected system. So that would be you in this classroom right now, right? You don't necessarily have physical access to the servers, but you're local. Okay. You have physical or logical accesses to systems that you can affect. Adjacent network is very similar to that. You have access to the local network that the affected system is connected to. Okay, so say if you wanted to hack into my laptop in my office, you're adjacent to it. You're not, because you're connected to the wires. So you just have to figure out how to get to it, see if you can attack. Okay. Next one is going to be the complexity of the attack. High complexity exploiting the vulnerability requires specialized conditions that would be difficult to find. Low complexity exploiting the vulnerability does not require any specialized conditions. Why would a low complexity have a higher number than the high complexity? I would get this. Yeah, so it's Mondays. Forgive me, but we've done a lab using Calvi and Metasploit, right? So if you can just let Metasploit select the default vulnerability, you're running to get something. My system's going, it's bad, right? That's bad. It's like, dude, it'd be past your system. So that's why. So it requires a very low level of steps to take. And it also, this one too, is it also requires a very low level of skill to do. See what I mean? So anybody, the high specialized conditions. Maybe you have to create some conditions. Maybe you have to have a higher skill set. Maybe it requires that you pivot through another system. So maybe you want to attack the server that I connected to on my laptop, but you want to get from this system to my laptop and then through my laptop to another system. That's specialized skills. Okay. Privileges required is the next one. Okay. Again, we'll start the very top one, right? High privileges. Attackers require administrative privileges to conduct the attack. So you either have to compromise an account that has those high privileges, or you have to do a privilege escalation. You have to take a low privilege account and privilege escalate it to either gain access to high privileges or compromise it, get high privilege on the privilege escalation attack. So that lowers the score though, because there's more steps to do. This is kind of a complexity rating here too. Okay. Low, attackers require basic user privileges to conduct the attack. That's not that great, right? I need low privileges and then none. Attackers do not need to authenticate to exploit the vulnerability. That's the highest level. Okay. That's like scanning. That's like doing your Nmap scan or your Nessus scan. And maybe you find a vulnerable old like Apache Tomcat server and then you run an attack for it and boom, you've got access at the root level to it. Okay. See why that's so high? up there at 0.85. User interaction, no user interaction. Successful exploitation does not require any action by any other user than the attacker. Required, it requires action by a user other than the attacker. That, again, that Tomcat server exploit, old Tomcat server, right? The end user requires no interaction for it, okay? Lower rating, or higher rating, sorry. And then successful exploitation. Think if you're trying to maybe social engineer somebody. So maybe you email a compromised PDF file to that user, and there's a Trojan inside that compromised PDF file. That file can sit in the user inbox forever and nothing will happen, right? Unless the user clicks on it, right? So it's a lower threat because it may or may not happen. Confidentiality metric, no confidentiality impact to some information is possible to high, all. Okay. This could be a lot of times I'll see this in the accessing passwords and username information on databases, right? If there's no confidential impact to it, if it doesn't compromise user accounts and passwords, we're going to have a low score in this area. Okay. But if say it gives you full access to, say, a decrypted version of ntds.dit. Anybody taken their Windows Server course yet? What do you think? ntds.dit is where every user account and password and permissions are stored for an entire Windows Active Directory. So you see how that, and there is malware and viruses and exploits out there that will reveal that to you, to provide that to you. Right, that's going to be a full-blown 0.56 on this one, right? And these are all, as you can probably guess, these are all like multiplication factors, so that's why they're low like this. Okay, integrity impact, no integrity impact, 0. Integrity of a system is totally compromised, and the attacker may change any information at will, 0.56, and then we have a middling value there. Okay, availability. Can we know availability? This is basically systems or services being online or offline. A little scenario on this one from a CCDC competition a few years ago. One of our hackers, our red team hackers, they compromised the student competitor's server system, and then they deployed a BIOS patch to the server, and the BIOS patch was basically corrupted. So what that did is that essentially ensured that when the students rebooted the server, it would be bricked, basically. It just wouldn't boot at all. You see how that would be? The system is completely shut down. And when do we have to reboot servers a lot, or computers a lot? Like patches, applying security patches. So the CCDC competition, a lot of fun. You're a student next spring. It's already started this spring. We've left the other team with. But in the CCDC competition, you basically sit down as a student competition team and you start securing networks with the scenario in mind. And then at the same time, you in your group, red team hackers start hacking your network. And your goal is to secure the network and maintain service uptime on here. So what the hackers did, the hacker knew that the students were going to have to reboot the server after they deployed security patches to it. And then when they rebooted the server died. I always applaud people that create new memos. There became a new red team rule in the competition that they cannot do that anymore because it is a competition. While it is a competition and their goal is to take the services down, the also point is for the students to learn and have success. And if your server just is completely bricked in a BIOS flash, there's no point in the game anymore. Right. So, but that's availability. That's a fun one for availability. Scope metric, right? The exploited vulnerability can only affect resources managed by the same security authority, or the exploited vulnerability can affect resources beyond the scope of the security authority managing the component containing the vulnerability. So that could be, did a threat actor compromise your local account password on the computer sitting on, or did they compromise like a domain account on that computer? They can log on to multiple systems across the network, okay? Or do they compromise like a really high credential, like say your Google account password? They compromise that service. I log on to like 8 to 10 different things with one Google password that aren't Google, right? So you can see how that, if they compromise that high, how it would be on the scope of authority managing it. Okay. So let's look at one here. interpreting the CVSS vector. This is straight from your book. So you'll be able to see this one again. This is the way it all looks in here. We have the attack vector, and then we have scores, right? We have these following scores here. Okay. We have confidentiality high, and then we have integrity none, availability none. So in a hypothetical situation, you have this. These are the numbers that you come up with for a particular vulnerability. Okay. What we do is that we now have to summarize those scores. So we figure out the exploitability score, the impact score, the impact function, and that turns into the CVSS base score. Do not get intimidated. This is surprise math, but it's not difficult math. Okay. This is basically how you do it. Your impact subscore, your ISS, you take 1 and then you subtract the confidentiality score. All right. So in here, it would be 1 minus 0.56. 1 minus integrity, which is 0. 1 minus availability, which was 0 for this one. And you multiply them together. Okay. And so in this one, right, we have a 1 minus 0.56. We have a 1 minus, and we end up with an ISS score of 0.56. Which is just real. This is really basic middle school math. They don't make this difficult because they know that if they make it too difficult, we're never going to be able to do it. Okay. The next thing you do is you calculate the impact score. Okay. So if the scope metric is unchanged, we multiply this by 6.42. Okay. So if we look back here on this one, the scope is unchanged. If the scope is changed, then we plug in a bigger formula. Okay. Then we calculate the exploitability score. Same simple thing. All we're doing is we're plugging in values, and we're multiplying them by these different types of constants in here. And then we come up with an exploitability of 3.89. Okay. Now for the base score, this is how we make it. If the impact is 0, the base score is 0. 0 impact, 0 no score, right? No threat. If the scope metric is unchanged, then we add together the impact and exploitability scores. If the scope metric is changed, we calculate the base score, we add together the impact and exploitability scores, and we multiply by 1.08. Don't ask me where people get these 1.08s and these 6.22s. For me, it doesn't matter. We just do the math on there. Okay. Now we know the highest possible base score is 10. If our calculation value is higher than 10, the base score is still 10. Okay. And then here's our range of CVSS base scores. 0 is none, 0.1 to 3.9 is low, 4.60 to 6.9 medium, 7.0, 8.9 high, 9 to 10 critical. But this starts making sense now, right? About what we want to communicate to them. And so I'll go back to this real quick. When I get like 1,000 different vulnerabilities, which I've seen thousands of vulnerabilities in a vulnerability scan across the enterprise before. But what do I want to talk about? Right? It's easy for me because I go straight to the criticals. Okay? Especially if I get tons and tons of criticals, I'm not too worried about the other ones if I've got the criticals, because I need to remediate critical before I worry about highs. Now, that being said, I will probably communicate your highs and criticals no matter what all the time, because sometimes your highs can be low-hanging fruit like patching, and your criticals can be low-hanging fruit like patching. But what I wouldn't say is don't always ignore the mediums or even the lows. They can be ways to get into systems in specific circumstances. But when I'm threat hunting, say if I'm in an incident and I'm hunting for threats, I'm deploying tools. These tools are giving me results. A lot of these results are based on our CVSS base scores. I almost ignore anything under a 5. Don't even care about it for NCS. And I start looking for the 6s to 10s in there. And if I don't have any 6s to 10s, I start thinking about, so what else is going on in this network? Why do I have a threat actor or a threat in here, but my CVSS scores are all low? So then I start looking at the lower ones and seeing for special circumstances on those lower ones. It can be quite interesting. And where I'm saying with that, so in an incident, we can deploy tools like Carbon Black or CrowdStrike Falcon, and it will deploy agents out to every workstation and server computer in your environment. And then it will start scanning the computer, look at the processes running, look at what's in the memory, look at files on disk, and it will start coming back with vulnerabilities and recommendations or even like TTPs that it sees based on, and it will give it, and it will use the CVSS score, because we all know how to interpret CVSS scores. It's easy, right? 0 through 10. Okay, so that's how, a little different. So now we have our lows through criticals, but we have to do something else. We have to validate. I want to validate my scan results. What if my scanner says that I have a critical vulnerability on Apache Tomcat, I don't know, version 5.6.8, not a real version, and I need to remediate it, okay? And that's critical, it's a 10. Before I communicate that to people, I want to do everything I can to validate that result, okay? So what we have on this is we have this grid here, positive report, negative report, and then accurate and inaccurate, okay? Sometimes a scanner can say, oh, I see this little piece of information, and I see this little piece of information, and I see this little piece of information. If I put them together, that equals, say, this Tomcat vulnerability. But what if I go and look at that server and real quick look at running processes, look at what it's intended for, and there's Tomcat doesn't exist on that server. Like the software is not there and the service is not running, right? What would that be? What would you think that would be on this grid?
False.
Yeah, false positive report because it's inaccurate. It's an easy grid, right? Okay. So what you want to do is you really want to analyze your results and you want to report the true positives, right? You want to report true positives. Okay. In a security operations center, you want to expand this. Say it's a security alert, right? You want to look at your true negatives. You want to look at your false positives and your false negative reports, and you want to understand why they caused that, why they alerted it. And maybe you can tune and change the query language to turn these into false positives or true negatives, right? True negative is not a bad thing, right? You're basically trying to prove something's not there, not true negative. So let's look through here, okay? So documented exceptions. We've talked about this in some previous classroom sessions, okay? But sometimes an organization may decide not to remediate vulnerability for one reason or another. So we need to know about that, right? If my company is making a business strategic decision not to remediate a vulnerability, I need to know about that. I need to know that's the decision made. What do I need to do? What do you think I need to do? If I know that they made this, say I have a server that runs like a critical database line, and for one reason of the IT department could say to not to remediate the vulnerability. And what do I need to do on the security side? Document it, keep it. Okay. What else? That this they put capitalisms. And right now, I now have this critical vulnerability with like my date. Okay. So I need to build up layers of defenses around that. So logging on, maybe I want firewall a little bit. Maybe I want session, other types of protection fraud. Maybe I want to add an upgrade security to it. But I want to increase our knowledge on it. And I want to, maybe if I'm set up, I have like a high value target space within my SIM. Essentially, just a table of hey, like a known vulnerable target that I'm going to do. So whenever there's log activity that seems suspicious, maybe we have some type of metrics like what show or CBSS that maybe multiplies that. Like, oh man, I think this is going to be like a P4 informational alert, which we don't really care about. Know that this is like a high value system that we've intentionally left vulnerable. So just apply to alert package by 1.5 or 0.8 or 2 or 3 or 4 to raise the alert levels to some of the best go in. This is what happened to Equifax now more than 10 years ago. They had the community discovered a critical vulnerability to Apache struts. And Apache struts is just part of the big Apache network on how data flows throughout, is presented to people. The Apache product is huge. But what happened was Apache was just like, hey, we know about it, and we've got it in the development queue to have a vulnerability, remediation for this vulnerability to be released in Jan. It was April. Okay. Equifax chose to do nothing and wait for the patch. In between the decision to do nothing and wait for patch being deployed, a threat actor discovered the vulnerability and thus uproot the data of our credit scores and social security numbers. Okay. What could they have done? They could have said, yeah, this is an incredibly vulnerable system. It's a CVSS 9. I forget what the vulnerability was on it. You can look it up. But they could have said, you know what? We need to do full log monitoring. We need to do full packet capture on this device. We need to purchase a system. We need to figure out more vulnerabilities on it, but we need to shore up our defenses on this system. And that was never done. Maybe you see the failure in that? Just because there may be a very valid and very strategic reason to not patch a vulnerability or to not remediate a system, but you have to do something to protect it some way. I've worked with companies, say a utility provider. Okay, we'll go with like a telephone company. Those telephone switches, the telephony equipment they use, can cost millions and millions of dollars. They're not going to upgrade the system every year. They're not going to buy a new one just because they feel like it. They're going to basically use that system as long as they possibly can, and then decom it when it can't service customers and when it can't make any money for them. Okay, so you may have a 15-year-old piece of network equipment that's a critical component of a telephone company, and it's being controlled by Windows 7. Okay, what do we know about Windows 7? It's about 20 years old. It's incredibly vulnerable, right? There's no way to patch it anymore. Microsoft is done. So what can we do? We can isolate it from the network. We can increase logging and double firewall it. We can, we can air gap it from the network. Maybe there's never a reason for this device to talk to anything on the network. It controls a piece of equipment, and there's an Ethernet cable plugged into it, but there's no good reason for that. So pull the cable out. It can't be hacked, right? Anybody read Game of Thrones or know who George R.R. Martin is? That's what he talks about, is that he has the most secure writing setup ever, because he still writes on like an old 1990s computer that doesn't even have a modem in it. So he just types and puts his 5.5-inch floppy disks in and then moves it around. But nobody can ever hack it because it's not connected to a network. Okay? So we have to understand that we may decide that for one reason or another, somebody may decide not to remediate a vulnerability. There needs to be a reason. Okay? You need to record it, document them. The thing is that you need to communicate it too. Like, if the SOC doesn't know, they're going to freak out, right? Or if the SOC does know, then they can enhance their response if they see some weird activity going on. Okay? And then it can reduce the level of noise in your scan reports, right? You can just mark it. Hey, this is a known vulnerability. We're not going to do anything with it in your reports. Don't tell me about this again. I know about it. Your SIM, a lot of SIMs will do that. So you can buy service Qualys, and you don't even have to read the Qualys reports. The Qualys data will get uploaded into your SIM, and your SIM can alert you on that. Same thing with Nessus. You can put an agent on your Nessus scanning computer, and every time it runs a Nessus scan of your network, it will upload a report to the SIM, and the SIM will take action on it if it feels like it needs to. You don't have to look at it if you don't want to. Okay? You've seen this before. This is Nessus. Okay? These are just your information reports, and it's going to tell you about the different types of vulnerabilities. It's going to tell you how many systems are there in, and it's going to give you the generalized family. That's where it says, like it says, CGI abuses, web servers. Those are the families of attacks, okay? And then the count column is how many. Okay. How do we get all this data then? Okay, so when we talk about reconciling these scan results with other data sources, so this is the way that we validate. What do our logs show? Do our logs confirm our scans? What about our configuration management? We get a scan result that reports us a result, but then we look at our configuration management and say, no, that's not possible. So we have another false positive, right? Or we could confirm it. Scan result says that it did a credentialed scan with the user account, and this user had access to, say, an executive level share. You can go into Active Directory users and computers and be like, oh, wow, that user account does have the ability to do that. So let's make a config change. Okay, so this is validating the results. Trend lines, I'm sorry, this one's really small. I like to watch trend lines. This goes back to that poster up there, no normal, find evil. Okay, humans are very visual people. Do you agree with that? Disagree with that? Yeah. Think about, and even have you ever like opened up a big, massive, nasty spreadsheet and just gotten completely overwhelmed with it? Like, I don't even know, this doesn't make, right? You see where I'm going through that? But then if you convert that to visual information, okay, look at these peaks and valleys on these reports, and that's for vulnerability trends by severity. So you see the vulnerability trends going up and then going down. What do you think's making them go down in the scan? Patching, remediating, and then they go back up again, and then maybe they go back down again. These are good things that you can provide in management reports. Say you're getting audited. Say you need to do a report on your PCI audit results. You can say, look, we're doing work. Look, our quarterly scans are coming up with these things, but then we're remediating them. And this is how fast we're remediating them. This is what I like about visual charts and graphs. I mean, for me, these are things that I copy and paste into emails and reports. And look at what my team did. Look at all the remediation work that happened. Or hey, these look like they're quarterly scans in this upper left-hand chart. What happens if the next quarterly one, man, that valley stays the same and it turns into a plane, right? Holy cow! Look at how awesome our department is. We had 0 critical vulnerabilities this time around, or we had half as much. These are good things to report to your management. Okay. Now let's hit common vulnerabilities. I know we're getting long here. Okay. This data goes up to 2015. That's what your size of plus is based on. What I will say is that it's relatively the same now. It's just new and different CVEs that affect our servers and endpoint vulnerabilities. Okay. And most of them are, as you mentioned, Michael, missing patches. Most of our critical vulnerabilities can be remediated simply by applying a patch. And I've told the story of Maricopa County and billions of dollars of liabilities for that and all on a missing patch. It's easy to patch a system. Most, not all patches for Linux and Windows do not even require a reboot anymore. Okay. Unsupported operating systems and applications. This goes back to my Windows 7 mention. There's nothing you can do about an unsupported operating system except air gap it, limit access. But a lot of these exist out here. Okay. We've talked about a bunch of these too already, but a buffer overflow. Okay. A buffer overflow occurs when an attacker manipulates the program and they basically go outside of the allocated memory for that program. And then a lot of times you can get a command prompt, or a lot of times they get space and memory where they can say, and you'll do this in the ethical hacking course where they can use Python script, because Python is built into a lot of Linux servers, and they can get a bash prompt. And that bash prompt more than likely has root level access when they do that via a buffer overflow. Okay. Privilege escalation. This is where they look to increase the level of access from what you currently have. So this is how do I get from, we call it from boot to root, basically. So how do I get from user level credentials to root level credentials? Okay, we'll do some of these in the hacking class. There might be one, I need to look at the labs, but we'll look at the labs too. There might be one of these in here. Arbitrary code execution. Okay, this is essentially the improper processing of packets for this particular one. Okay, arbitrary code execution basically says that the vulnerability means that any type of executable code can be run. Insecure protocol use. Why do we use SSH and SCP and we no longer use FTP or Telnet? Right? Everything in FTP and Telnet is done in plain text, unencrypted packets. When you type your username in and send it to an FTP server, your username goes out unencrypted. When it replies back, it says, okay, now it's your password. Your password goes out unencrypted. Okay. SSL, SCP, FTPS don't necessarily do that. Okay. Because the communication, where it says FTPS, that's FTP over SSL over TLS. The FTP protocol is still insecure, but FTPS ensures that it's going out via that SSL, secure sockets layer or transportation layer encryption protocol. So FTP is still insecure, but it's being transmitted in a secure manner. Debugging mode. This is an interesting one that you may not have heard about, but remember, and with this particular example, Microsoft always wants to be helpful. Okay, so debugging mode is essentially a mode that you can put most devices into, and it gives you detailed logs of what's going on. So if there's an error or a problem's happening, or you can't get something to work, there's going to be a debug log, and it's going to tell you this happened, this happened, this happened, and you can take that information and you can fix it. Okay, with Microsoft and particularly active server pages.net, if there's a coding error or something weird happens when you go to an active server page, it could quite possibly give you debug output to your web browser. A hacker can then use that debug output to figure out how to take advantage of that system. Okay. The solution for this one, for mitigations, is to make sure your debug statements are turned off to the public, or they're only usable by authenticated users. So you have to authenticate with the server before you get debug logs. Okay. But a debug log can tell you a lot. Outdated SSL and TLS versions. Remember that computers want to communicate with each other. So say if we're using transportation layer security 3, but our client that's trying to communicate with us only has 1 or 2 available, if my system is misconfigured, it may try to negotiate down to a lower SSL version. But why do we have a newer secure socket layer version or TLS version? Because the previous ones are vulnerable, right? So what we essentially want to do is we want to configure our systems to say only use this version of SSL or TLS. However, we go back to that mitigate. We go back to that. Maybe we're in a corporate environment and we've rolled out our own code, so we're coding stuff, and we have to remain at SSL 2.0 until our developers upgrade the internal product to accept SSL 3.0. See? So it's not always black and white with some of this stuff. Insecure cipher use goes similar to this. Okay. SSL cipher suite supported, and this is RC4. Okay. RC4 is a weak cipher. It's plain and simple. It's a weak cipher. Windows, again, wants to be helpful. And in some situations, you can force Windows to even communicate with an RC4 type cipher. It's vulnerable. We can decrypt it. Linux, old applications. Okay. So yeah, and this is a common attack here to mention too. The second paragraph, and like I said, it's in your textbook, so you can read it better in your textbook. But the second paragraph here says, if plain text is repeatedly encrypted and an attacker is able to obtain ciphertext, the attacker may be able to derive the plain text. That makes sense though, right? If I know what sequence the password is going to be transmitted, and that same cipher gets transmitted over and over and over again, I can probably either brute force attack that offline, or heck, I can just steal that and transmit that series of bytes instead, okay? But insecure cipher use. The solution is reconfigure the application, right? Avoid RC4 ciphers. Move over to TLS 1.2 or AES. Those are more advanced ciphered, or more advanced ones. Okay, yeah, I know we're getting a little long here, but we're getting close. Security, certificate problems, common errors, mismatched name of the certificate, expiration of the digital certificate, unknown certificate authority, okay? These are just common issues that can pop up with certificates, okay? They can lead to things like this. Have you ever seen this in your web browser before, right? And you have to click on advanced, and then you have the back to safety. I did this last night. It was just an old website I needed to get information on. What it's telling you is that the certificate, there's a certificate error and you don't have a secure communication channel. That's all. That's what this means. So you can proceed unsecurely, or you can go back and not use it. Okay. DNS attacks can happen to us. Okay. The biggest things for DNS attacks is restrict access to your internal DNS servers to internal systems. Don't let public systems from outside use your DNS servers. Internal IP address disclosures. Go back to that ASP.NET error. What happens if that ASP server is debug log discloses, say, the internal IP address of a server?
Correct.
The attacker now knows the internal IP address server, and more, they know the IP address structure of the network. Even more, we tend to segregate systems out. So our users are in one group of IP addresses, our servers are in another group of IP addresses. So they now know the approximate range of IP addresses and where other servers may be internally. Okay. Virtualization vulnerabilities. So virtualization essentially is running an operating system on another operating system, right? The goal here is this is kind of what it looks like. We have, say, 3 virtual guest systems or virtual host system that are inside a hypervisor. A hypervisor is going to be like VMware Workstation or ESXi or Hyper-V, or on the Linux side, libvirt. Okay, that's the hypervisor. The goal of the hacker is going to be to escape the virtual guest and gain access to the hypervisor. Hypervisor is more than likely going to be a customized version of Linux. So you want to get root access to Linux and hypervisor, and you can go wherever you want on there. Okay, so we can have VM escape. We can try to get access to the management interface. Every virtualization product out there has a management interface to it. We can patch, take advantage of virtual guest vulnerabilities. So typically, without any type of aid, you can't like cut and paste between a virtual machine and your host system, but you can add virtual machine guest software on there, and it will enable that communication between the host and the guest virtual machine. So think about that. Could you take advantage of that? Maybe. Okay. And then virtual network issues. Whenever you deploy VMware, obviously I may not be able to do it. We'll see if it lets me move my permissions here. So this is essentially VMware Workstation. It's my hypervisor. But I can go to Virtual Network Editor, and I have a virtual network set up in here. Okay. See, I might be pushing the permissions levels here. If I go to network connections here, let's see what's going yet. Yep. Okay. So if I go into my network connections, my adapter options, look, this is the physical network port where my Ethernet cable is plugged into. But look, I have VM Network Adapter 1 for VMNet 1, VM Network Adapter 2 for VMNet 8. And we see VMNet 1, VMNet 8. So your data packets are kind of moving through the physical host. So could you find a way to take advantage of this? Could your threat actor find a way to take advantage of this? They might be able to. Okay, IoT stuff. We all have Internet of Things going on, right? I mean, I've got Apple Watch on. Do you have any of you have a virtual watch on or a smart watch on? Fitbit? Yeah. This phone is probably this phone, the HVAC controller, the projector is an IoT device. IoT's everywhere, right? Even down to, I have a Mister that connects to my Wi-Fi network. That's IoT. Nanny cams, IoT. Alexa, Google Home, IoT. Okay? All of those things are running things like embedded systems, real-time operating systems, system on a chip, field programmable gate arrays, and then controller area network bus. Anybody up on cars at all? Airplanes and cars run on a CAN bus network, not so much on FPGAs here. System on a chip. Lots of your IoT devices that you buy on Amazon or Walmart or Target, wherever, they're going to run embedded versions of Linux. That's system on a chip or an embedded system also. And they'll run Windows that way. Real-time operating systems, those are going to be customized operating systems. Typically, they'll run scientific devices, scientific systems. A good example of that is our satellites and maybe a lot of stuff that NASA uses. That level thing. There's one called Wind River, and it's just a popular lightweight real-time operating system. So think about Windows or think about Linux, but then how light of an operating system can we put on a chip that does exactly what we need and nothing more? And those are your real-time operating systems, your systems on a chip. What about another one? I have a couple of these at home. Like the Windows sticks. Have you seen the Windows sticks? You can buy them for about $100, and they're about this long, about that big, and they have an HDMI port on them, and you can stick them into your TV, and now you have Windows on your TV. That would be an embedded system. They'd be running Windows embedded. Okay. Web application vulnerabilities. We've got injection attacks. Sorry about the slide. It looked better an hour or two ago. Cross-site scripting, and then we have this directory traversal attacks. Okay. SQL injection, another small one here. Okay. SQL injection is nothing more than sending handcrafted SQL codes through a web page, and you're trying to get some sort of response from your server. Okay. It's not a good example on this slide, but we do have a SQL injection attack lab. Okay, and you'll see what happens. But essentially, the idea of a SQL injection attack is I've got a web page with boxes to input data in. What happens if I put a SQL command in there rather than say first name? It wants me to put JSON in there, but instead I put a SQL command in there. Maybe it'll respond with data. Maybe I put in show star from users, and if there's a users table, it might show me all the usernames in that table, right? Or I could say drop users, and that would basically delete the user table. So you see what we can do with this? Okay, so you will do a SQL injection attack in your lab, and you'll see the real vulnerabilities. This goes back to insecure coding, right? If it says first name, think about the programmer should think about what is the reasonable amount of characters for a first name. I'd say 15 to 20 these days, and that's it. Right? Maybe no spaces. Maybe allow one space character in there. Secure coding, input validation. Input validation, secure coding should stop SQL injection attack. Okay. Cross-site scripting. There's 3 different types of cross-site scripting attacks. We have persistent, XSS, reflected, and then document object model. Okay. You're going to do cross-site scripting attack labs. Okay. Essentially, a cross-site scripting attack is a failure for the host to sanitize the data strings, and then you can use those maliciously. Okay. So what you can do then is then it says here that the attacker can cause arbitrary HTML and script code to be executed. Okay. But it's working within the context of the security of the web page. So if the web page is operating as root, the cross-site scripting attack will execute the script as root. Okay. Solution: restrict access to vulnerable application. Okay. And you will have a lab on that one. Okay. Super close here. Authentication vulnerabilities. We got password reuse, session hijacking, man-in-the-middle attack, and then impersonation. We're not going to go into detail on all of those, but we are going to hit password reuse. Okay. How many people have the same password? How many of you have the same password for different applications or websites or whatever? I'll raise my hand. Me. Okay. So that's one way. Okay. Now we get into what we call a password spraying attack. Okay. This is where I take, say, the top 10 passwords in an organization, and I quite literally spray them around every user account. Let me try. Let me try this password. Let me try this password. Let me try this password. Let me see what kind of hits I get. You would be surprised at the success of it. Mitigations for that, since we don't talk about many mitigations, is that if we have Jason, Michael, and Cynthia, and say I'm gonna spray password, I could say, well, what happened? I could configure alert. It's gonna get turned into the same password hash, right? But the same password is gonna get reused. So what if the same password gets used across 3 accounts within, say, 2 minutes? Think I could alert on that? Think I could write some kind of query to create an alert for that? Because in these days of complex passwords, right? Say my password is crazy complex password 1 exclamation point, right? And that password gets used 3 times, like on 3 different accounts at almost the same time. That's an alert. Okay. And then credential stuffing attacks occur when a user takes a list of usernames and passwords that were stolen in the compromise of one website and uses them to gain access to a different, potentially unrelated website. Okay. You will do this in this course and in the hacking course. Kali Linux has leaked passwords. I believe it's called let's see if I can pull it up. Let's see here. Okay, here we go. Look at this. This is just a Google search real quick to show you. Hopefully you know what GitHub is by now. If you don't, learn what GitHub is. But this is 5 gigabyte compressed file, a large list of leaked passwords I've collected and consolidated, all stored on a Google Drive. How many passwords is 5 gigabytes worth of passwords? Okay, different databases, right? Look, top passwords short list, top 20 common SSH passwords, medical device passwords. Guess what? Manufacturers embed and hard code usernames and passwords into all kinds of stuff. 500 worst passwords, 10,000. Okay, the idea is that when you're doing these password attacks, it takes a short amount of time to spray 20 common passwords, or to use like Hashcat or Cain and Abel to decrypt a small set of passwords, say less than 1,000 or so. But it's going to take forever to run. To think about it. Think about if you spray 10 million passwords across the 3 of us. How long is that going to take? Or if you attempted, or if the 3 of us had a complex password and then we brute forced 10 million possible passwords against it, it's going to take a long time. Okay, so but this is some good stuff. Leaked databases, Artash is popular. Default credential data. Look at it. Default credential. IoT. See, default credentials for IoT devices. And SCADA. I mentioned Tomcat, right? VNC passwords would see how, so they've curated this against possible targets too. And this is how I found that out. I typed leaked password to GitHub and look at all the other results I got. Okay. Kali Linux will have a couple in there already. Okay. Get back over here. Man-in-the-middle attack. That's essentially, right, if we use the Alice Bobby thing, I hope you've seen some of those videos before. Alice is working with a bank server. Okay. But Alice gets intercepted and an attacker, or maybe say Bob, gets in the middle of that. The attacker may have a way to intercept Alice's password. Okay. They may not have to even decrypt the password. They could just stuff it in there, reuse it, transmit the encryption themselves. They could say that this works for a lot of situations. This even works for Wi-Fi. Okay. If you were to log in securely to this Wi-Fi access point, I can also listen. And if your password is repeated enough times and reused enough times, I can gather enough data to crack your password and then insert myself into the middle of that. Okay. I can turn on a device called this is a cool one here. The types of man-in-the-middle attacks are endless. But I could take a device like this called a Wi-Fi Pineapple and see how it has 3 antennas on it. How many Wi-Fi cards do you think are in this thing? Wi-Fi networks is it able to talk to at one time? 3. Okay. So what if I use one of these, and on one of these antennas, I name it DCCD student, and then I crank the power out to that thing to like 150%. Like I make it the most powerful Wi-Fi access point broadcasting DCCD student in this room. And hopefully more powerful than that. Okay. And then I take another one of these antennas and I connect it to this. And then I'm acting as like a pass-through point on here. You're going to connect to me, but then this device is going to allow you to pass through to that Wi-Fi access point. As far as you're concerned, everything's normal, right? And then I'm connected to the third antenna wirelessly somewhere. I could drop this device in this room and I could go into my office and I could be connected to it. And I could be watching everything going on. Okay. And look how much this thing costs. $120. Kind of expensive from a consumer level. How much do you think it is from a business level? Nothing, right? And then just like Nessus does, you can assess it too. That the man-in-the-middle attack is just one thing this thing's capable of. Okay. So that there's so many different versions of a man-in-the-middle attack. So it can go everywhere from being in the middle of a web session or a network session or even physical. Okay. Physical even being Wi-Fi or even on the Ethernet networks. I can get in the middle of it. Okay. And that's the last slide. Ta-da! Last slide. That was 50 slides. Okay. Let's have a real quick look at this. Okay. We got the ebook. We got the quiz. We've got 8 labs, I think. 1, 2, 3, 4, 5, 6, 7, 8 labs. Okay. And then I'll throw an exit ticket in there too. Okay. We are going to be looking at, you're going to be explained by pay attention to exploiting a website using SQL injection, CSRF attacks, buffer overload. All of these are really good things to be aware of. So you're going to do some of these attacks. And that's the cool thing. I truly believe that to detect hackers, you kind of have to do some hacking yourself. Again, that's no normal find evil, right? You have to understand how evil acts. Okay. Most of these are going to involve using what's called the damn vulnerable web app. Okay. So the cool thing is you can Google damn vulnerable web application and you can install this in your home lab. And then you can download Kali Linux and you can do this at home, where you can do all the different scenarios too of what the damn vulnerable web app does. Okay. Very easy ways to deploy this thing too. Okay. But most of these labs will involve the damn vulnerable web app, which it's really cool because it has every type of vulnerability you can think of for web applications. And it's not complex attacks, but it's showing you how to perform the attack. And then what you can do from my side of things is that you could perform the attack and I could be like, okay, I performed a cross-site scripting attack at 10:34 a.m. Okay. Now let me go into the logs of the system that app was running on. And let me see what the logs say about what I did. Same thing with all of these attacks. Okay. What do the logs say? So, and then the question from a cybersecurity analyst standpoint, especially if you're working in the SOC is can I perform the attack? Can I look at the logs? Can I look at the running processes? Can I look at the memory? And can I create an alert? Or can I go look at my SIM and I know the logs that were created. Can I go find those logs on my SIM? If my logs aren't getting to the SIM, what's the problem with that? Then go ahead, Michael. You won't get anything, right? If the right logs aren't getting to the SIM, you won't get anything. So, now I know that I need to make sure that the right logs are getting to the SIM. And then all of a sudden the data starts flowing in and I start getting alerts and information. So that's how you can do this very simply, very easily. Or you could so one of the things with Windows, when we move into PowerShell type attacks, very minimal basic PowerShell logging is turned on because PowerShell is used so heavily. However, lots of attacks use PowerShell also. So you might say, I'm going to test using PowerShell Empire. We're way out of scope of this, but we're now on log detection. I'm going to use PowerShell. I want to detect PowerShell Empire activity. I can't find any activity, even though I did some on my Windows server, Kali. Do some research. What you'll find out is that the detailed PowerShell logging is turned off by Microsoft by default. So what's your mitigation recommendation? Turn it on, right? Now, it can be so big on that one. What I'll do, just from a practical like incident response level on that one, is I will come in there and it's more than likely turned off because it generates a ton of logs. So I might tell my customer client, hey, for the duration of this incident, I need you to make this change. I need you to turn on PowerShell script log logging, push out a Active Directory change throughout your network to turn this on everything. And then all those logs that come flowing in, and we'll get so many of that stuff. And then when we declare the incident over, turn it off or turn it down. Okay. So these are all really good stuff for you to learn. This is your Learn How to Be a Hacker module in this course, and we're focusing on web application penetration testing. We will be doing web application penetration testing for a week in the hacking course also. Okay. That's all I have. Don't forget about any remaining modules from last week. Michael, you asked me about seeing your score on the midterm. I think I changed the configuration setting on the test, so you should be able to see it. If not, I will fix that. Okay. And I haven't, if you did the review, I have not added those 10 extra points in yet. Go ahead, Cynthia. I'm sorry.